my rotary table is lined up with the center of the spindle, I now need to get the workpiece itself lined up underneath the spindle and get that tight into the vise and get the vise tight onto the rotary table. So that's going to be a little bit of manipulation there. Okay, but the first step would be to set this up in my vise the same way I set it up for when I went to drill the center holes. Again, I got my X as a reference that will go to the top of the vise. I have my block here that will allow me to make a stop. Put my parallel against there nice and tight. And now get everything nice and tight this way again. The same way I had it whenever I was doing the drill press work. To do the center hole with the drill press. Okay. So now we're back to where I was when I did the drill press work. The X, which just marks the reference, is up tight against the vise here, against the stop that was here. So it's now in the same position it was when it was being drilled. And so now I can take this and put this over on the road. What's going on here? I want to get this lined up inside the hole here now. Moving my vise, keeping my table tight, and getting this lined up here, and begin manipulating this a little bit back and forth here until I get it where I want it this direction here. And then I have a clamp back here that I can clamp. Let's double check. Okay, looks good. Okay, let me give you a little rundown of what I'm trying to accomplish here now. I don't know if I showed you these or not yet, but these are the ball bearings that I'm going to be using. They're 1/8 inch. They're 1/8 inch. Diameter ball bearings. Now, here's what I'm planning on doing. This is the top plate that I'm working on right now in my rotary table. I'm going to move my rotary table over so that I am now centered on the center line, on the hole here. I'm going to move my rotary table over so that I have an 1/8 inch milling cutter that will come over a certain radius from that center line, and then I'll turn my rotary table, and I'll make a circular groove for the ball bearings to ride in. That will be the top flange. The bottom flange will have to be reset back in my vise and reset again, and that will have 3 at a 120-degree angle here, 3 ball bearings that will be seated in here, that I'll use an 1/8 inch ball mill, and I will spot drill at 120 degrees, so I have a triangle here of 3 ball bearings seated, and that should give me the ability to make that rotate back and forth with the ball bearings. So right now, since I'm working on the top flange right now, I need to do a whole rotary table circumference cut around here, and that's what I'm getting ready to do next. I need to go on my plans here now and see what that radius is. And there it is, the offset 1/8 inch groove. It'll be 1/16 of an inch deep, which is 63 thousandths of an inch deep, and the radius is 144 thousandths of an inch off of the center, and that's what I need to work on now. Okay, I think I'm going to use my x-axis to bring that over that 140 thousandths, and I think I'm going to take it tight to here. That, put my 0 here, and then bring my table this direction, 144 thousandths. Just let me double check that here. 144 thousandths for the radius. So I'll move my x-axis now to 144 thousandths. 144. 144 thousandths. I'm cutting right now, I depth about 10 thousandths right now. just to see how it's going to react with the turn the rotary table. More cleanup pass. Alright. I'll take that over to the bench, clean it up, and see how the ball bearings run in it. So that's going to work fine for that. Okay, I'll do the rest of the 7 of these and then start working on these here. And that's coming up next. Okay, you can see right there. Now it's time to do the bottoms here. I'll just do the same thing again. I'll line everything up with my X mark here. Put my stop here. Make sure everything's nice and tight. Okay, now before I do this here spot drilling, every 120 degrees, I want to turn the table about 10 degrees, 5 degrees off each spot hole. I don't want just one spot hole at an 1/8 inch bit drilled down, or end-mill drilled down, but rather I want to come down and go both directions. I want about a 10 degrees of length of the circumference of the spot hole itself. I don't want just one little hole. I want it to be elongated a little bit, about 5 degrees both sides of it. So what I did here is I'm starting my rotary table here at 5 degrees below 0 here. I will plunge down my 1/16 of an inch, then I'll turn my rotary table 5 degrees past 0, and then I will go to the next setting, which would be 120 degrees, and then I'll go to 115 degrees to 125 degrees, and then I'll do the same thing, 235, 245, and just keep on going that way there. And that way I'll have a little bit of a groove instead of just a spot hole. I'll have a groove for the ball bearing to just ride in about 10 degrees of circumference. Start throwing my table about 10 degrees. Right there is 0. And 5 degrees. Now because of that, I can drill a ball bearing in there. And I have a little bit of wiggle room both directions of it. It can move back and forth this way here in a small groove, this way here. It's not just the width of the ball bearing itself now. It has a little bit of play back and forth this way, and that's what I want. About 10 degrees, 5 degrees off each center line. Okay, now I'll go ahead and I'll turn it to 120, and I'll come back 5 degrees off of that, and then do the same thing again, and then do the same thing at 240. And then I should have the 3 spot drills for the ball bearings for the bottom part of this here caster setup. Okay, I'll turn to 120 now. There's 10, 20, 30, 40, 50, 60, 80, 90, 100, 110, 120. Get rid of the backlash. 110 and 115. That's what I want, 115. Lock it. And we'll do the next one now. Now since I'm turning my okay, so you can see how that works out, and I'll do the same thing one more time over here. another 120 degrees, and then we'll check and see how that works with the top plate and the ball bearings. Ready? Let's see what we got here now. Okay, let's take it over and let's take a look and see how that works with the ball bearings here. Okay. So I can get you guys in focus here. I'm working at. There we go. One ball bearing. 2, 3 ball bearings. Take a top. Can you see what I'm doing? Right here. Okay. Now take a top plate that has the full groove in there, and a 440 screw. Got a long one here. And the 440 screw will eventually get it'll get Loctited into the bottom later on. Okay, let me get you zoomed out here a bit so we can get clearer here. Alright, so now the screw will be Loctite into the bottom flange, and then that will be the rotation part. Just loosen up a little bit. The bearings are set up in there. And depending on how tight I tighten the screw, but you can see the bearings down the side, I believe. They're riding along inside the groove and they're staying in their spots. Okay, that's going to work really good. Okay, now I noticed that on an actual picture of a caster here, the top plate is actually where the flange is at is thinner, and it allows the area where the ball bearings are at to be raised, like a raised area here. And that's what I think I'm going to do with my pieces too also. I'm going to try to raise this area here, and that would be with these here blanks here. Right now I have it down to this point right here, but it looks like what I can do is I can machine the corners down a little bit lower now, so that would give the groove a raised look, so that when you look at from this profile here, the ball bearing groove would have that raised look like shown over here. And I'll probably do the same for the bottom also. I'll probably do some sort of a shaping that would make that stand out more also. But right now the main thing is the top part right here, and that's the part that I want to start working on, getting that raised area here machined out. Okay, what I'm looking at here is this reveal inside here like this. That's about 60 some thou, 70 some thou, that area. I think what I'm going to do is I'm going to use this reveal from here to here and go all the way around. And the height of this is about 160 thou. I'm going to take this down 100 thou, around 100 thousandths, and have about a 60 thousandth, maybe a 16th of an inch reveal of plate left over in thickness, and this would raise this about 100 thousandths of an inch off of the plate here. So that's what I'm going to do with this here now at the mill. Okay, now here's where I'm at with this here. This here is about 160 thousandths, and I need to take down 100 thousandths off the top of this here where the groove is at to make that there ball bearing flange stick up. What I need to do though is I need to put this in my vise, and I need to clamp it at about 1/16 of an inch, and then come down and just barely touch onto my vise. I want to stay above the vise about 4 thousandths or so, thickness of a piece of paper. But my my parallels that I have, my vise jaw is 1 inch in height. My parallels, I have one set that goes to 1 inch, and the next one down to 7/8, and I have the small set I have here goes down to 7/8 of an inch. That gives me an 1/8 of an inch from the top of the parallel to the top of the vise. I need a 1/16 of an inch from the top of the vise down. so I can't use any kind of parallel for that. I'm going to have to make a small parallel, just a small little block. I just have to cut a small block that will put me a 1/16 of an inch below the top of my vise, and then I should be able to use that to locate this for height. Okay, let's put on the mill and see how it works. And I'll have my height, and I'll have it located this way and that way, because both references are on both reference surfaces, and that'll work real well. Okay, just like that. There's the height. There's the locator for the height. Again, like I said, the reference surface is here and across the front, and now you can see how much it protrudes up the top there. So now I can do the milling and clear the vise and come down about 1/16 of an inch and still clear the vise and have good support because I'm clamping right down on the block itself. What I need to do now is take the screw out of here and move the vise now in position to make it underneath the spindle here. And that's what I'm going to do here next. Times I'm going to make myself a good camera mount that I can put this camera in convenient places where I can actually do the work and let you swatch in at the same time. Right now I'm trying to position the camera and work around it, and so I'll see if I get a good view here. Here's what I'm talking about and doing now. I have the drill bit put back in here that I used for the clearance hole for this top flange. I'm going to loosen my vise now because I know the rotary table is back in position to be on center. I know that because I've moved it. What I'll do now is I'll just move my vise until I get my vise lined up even with the drill bit here, and then I can tighten the vise down. I remember I have that there bar underneath there, so I can't get too far down. Right there, looks that should be it right there. And now I'll have to readjust this to get the vise tight. Okay, I got myself clamped down here nice and tight now. I moved my vise over and just move this up a little bit here. And you can see, clearly see that it's back on center. It is on center. I have the vise lined up. So what I can do now is move my rotary table over to the outside of the block, and then I can use that as a gauge to know how much I'm going to be taking off around the whole perimeter now to bring this down, to bring that flange down. And that will cause the ball bearing race area to be raised off the surface to give it that look that we were looking at before. Okay, here we go. Okay, keeping the y-axis lock, I'll loosen the x-axis, and I'll start advancing the table on the x-axis. until my milling cutter is touching the edge of the workpiece on the reference edge here. I'm using a reference edge again, and I'll just move this until I'm touching right there, and I'll lock my x-axis, take it up here, and I'll now rotate this to get some, and I'll come down, I'll touch off now, and then I'll get my depth cut. Here I'm touching right there. I'm going to adjust that for about 60 thousandths. Okay, I'm not touching my vise, which is a good thing. I'll set my depth. I'll come back up and drop it 10 thousandths now for test cut. That's up now at 30 thousandths. Let me get that screw out of there. We'll check and see how it works. Okay, there it is. That's what it looks like. We went from this being square to this being rounded on the bottom. Looks nice. Okay, I got to do the rest of them now that way, and then we'll start working on the bottom for the wheel assembly. That'll be next after this. I like that. That's a nice. It's a nice addition to it. Nice. Looks nice. Okay.